Autism Spectrum Disorder by Chelsea Brooks and Erin Moriarty. So this music that's playing is composed by Wolfgang Mozart, who's on your right, and in the middle is Albert Einstein, and on the left is Sir Isaac Newton. So you're probably wondering why they're all on this slide together, and you can take your guesses now. So they're all on this slide together is because they all are suspected to have been on the autism spectrum. So what is autism? Autism is a developmental disorder, and it usually presents itself in the first 2 years of a child's life. And like I said before, it is a spectrum, so there are varying degrees. Children could be on complete opposite ends of the spectrum, and there are different levels indicating where the children are at with this disorder. So with the first 2 years, there are indicators such as your child not making eye contact, your child not responding to when you point to something, or like when you call their name. If they're not smiling, they're not laughing, it's usually a sign of concern. So with these, they may not have their first smile when you think they will, they may not have their first laugh when you think they will, and it takes a while for them to respond to their name. And so for the spectrum, there are varying degrees, level 1, 2, and 3, and with these varying degrees, there are different needs for different children on these different levels. And Chelsea will go into detail on the next slide.
Now that we have talked about what ASD is, there are different levels within the spectrum ranging from 1 to 3. The first level of ASD is known as high functioning. When a person is high functioning, they to a degree need a little support from someone else. People with level 1 will have difficulty starting interactions with people and will appear to not have an interest in social interactions. The symptoms of ASD aren't really as visible in this level. They will also have a difficult time switching to different activities from the previous activity that they were doing. Now, the second level of autism is usually known for the lack of nonverbal and verbal communication skills. People with level 2 autism need a bit more support than they do in level 1. The symptoms are a bit more noticeable than they would be in level 1. People with level 2 have a hard time dealing with change or focuses, and their behaviors will become more repetitive. So they'll keep doing something like flushing the toilet multiple times. Lastly, level 3, which is also known as low functioning, and a person with level 3 will require a lot of support and someone to always be there around the clock. With level 3, people will have severe impairments in functioning. They are very limited to social interactions, and they will have extreme difficulty dealing with change. They will also deal with a great amount of stress when they're trying to change their focus from one thing to another. To the right is a picture of a boy that I know whom has level 3 and is low functioning. His mother cannot work, for he has to have someone around the clock to watch him and to take care of him. He does not really communicate, and he only likes things that flash.
So you may be wondering why Chelsea and I picked this topic and why is it interesting to us. So did you know that boys are 5 times as likely to be diagnosed with autism than girls? We didn't, and we thought that was pretty interesting. Did you also know that there's no medical detection for autism? So just as like a blood test would indicate abnormalities for your blood, like there are no equivalent tests for autism. So there are questionnaires like the ASQ, which is the Ages and Stages questionnaire, which basically just tracks your child's development and if there are any signs of concern, but there are no equivalent tests such as a blood test for autism. And it also occurs in children that have older parents, and we thought that was interesting also, and we wanted to know why, and we thought genetics was the solution to our questions.
For many years, researchers have been trying to find the true genetic reason of what causes ASD. Like many other studies, researchers looked at twins. In an article I found, researchers looked at both monozygotic twins and dizygotic twins with autism spectrum disorder. These researchers found that monozygotic twins, if one had ASD, the other did as well. Whereas in dizygotic twins, if one had ASD, the other could have it, but there's also a chance that he or she doesn't, compared to if they were monozygotic. The researchers also went on to say that if one twin had ASD, the other twin is 50 times more likely to have ASD, unlike if it was one sibling who had ASD and then the other sibling having the chance of having ASD. The research relates to what we learned in class through Chapter 6.3 in our textbook. In Chapter 6.3, we talked about how monozygotic twins and dizygotic twins help us know whether if something is an environmental factor or a genetic factor. During this chapter, we looked at the concordance, which is the percentage in twin pairs that both twins will have a trait. We did this for many types of diseases or disorders. If the concordance is high in monozygotic twins than it is in dizygotic twins, there's a suggestion that genes influence that disease or disorder. The connection from the research in Chapter 6 suggests that since the ASD is higher in monozygotic twins than in dizygotic twins, that there is a gene involved rather than an environmental factor. It is just a matter of figuring out what type of gene and where that gene is. When researching about ASD, we will often see Fragile X syndrome appear. Fragile X syndrome is said to be one of the most leading causes to ASD. About 1 in 3 people with Fragile X syndrome have autism as well. Researchers have also noticed how if people with Fragile X don't have autism, they still have a difficult time with social interactions. The mutation on the FMR1 gene, which causes Fragile X, is also accounted for 5% of autism cases. In class, we first learned about Fragile X syndrome in Chapter 8.2. In this chapter, we talked about rare fragile states and how they are often associated with a set of nucleotide repeats that are high. Well, Fragile X has a fragile state, and that has an expanding nucleotide repeat that is often seen in males. Researchers and in Chapter 8.2 both went into saying that due to the trinucleotide CGG increasing to about 200 repeats in people with Fragile X syndrome compared to those without Fragile X syndrome who have a CGG trinucleotide count is about 54 repeats or even less. This shows us that there is an X-linked inheritance occurring and that the genetic factor that is involved and is causing the intellectual disability in Fragile X that has also been seen and most similar to those in autism is just becoming hard to pinpoint.
So the last connection that we made was to regulatory genes. This appears in our chapter 16.1 in our textbook. So it said that alterations in regular gene activity has led to autism. So how does this happen? So we all know from this chapter that regulatory genes they regulate the expression of the structural genes, which are further to the right, which are not drawn, but you can see the regulatory gene here. And that would affect their transcription or translation or even both. And it said that since these mutations happen, that it's not really inherited from a parent, that it happens spontaneously in the individual's genome. So it really doesn't come from your mom or your dad, it happens in the individual's genome spontaneously. And it is said that that mutations like this contribute to 25 to 30% of autism cases. And here are our sources to wrap it all up. Thank you.